Here we're going to look at a couple of examples of probability density function questions on exam 1. You should know by now that a probability density function is used to represent the probability of certain outcomes. We're talking about an area underneath the curve, and the area is representing the probability of something happening. The total area is always equal to 1. If we want to find the probability that x is less than something or greater than something, for example, with this one, if we had a PDF running between x equals 2 and x equals 5, and we wanted the probability that x was less than 3, we would be finding this area, and we'd be integrating that function between 3 and 2. So you've got to be really strong with your integration skills. You've got to be able to integrate a wide range of functions, linear functions, trig, perhaps exponential, any function really. If you're integrating trig functions, you might be substituting in. You've got to know your exact trig values. So there can be a fair bit that goes on with these questions. So you do need to have a really solid base of skills behind you. You may also be required to answer some conditional probability questions. So let's look at a couple of examples. The first one is we're given this function. It's a linear function, fx equals x on 12. The terminal's between 1 and 5. To help you, you may like to rough up a quick sketch. This would be a linear function with a y-intercept of 0, so it would head up something like this. But we would really only be interested in values between 1 and 5. So we might actually just rub out these little bits here and here. And we'll just make these dashed lines. And there's our area. So the first thing we want to do is find the probability that x is less than 3. So that's just as simple using the graph, if we can get it lined up. That's just as simple as finding the chance x is less than 3, so this area in here. So we're going to integrate the function between 3 and 1. That's for this question here. So if I was going to integrate this, I'd probably bring the 12th out the front and just integrate x. I think that'll make it a lot easier for us. So it's 1/12, and the integral of x is x squared on 2. Terminals 3 and 1. Sub them in. Which is a 12th times 3 squared on 2, that's 9 on 2, minus 1 on 2, which is 8 on 2, so 1/12 times 8 on 2, which is 4 twelfths, which is 1/3. And there's a couple of other ways of getting there, but your answer should be 1/3, and you must ensure that you simplify those really simple fractions. Now the second part of the question is asking if the probability of x being greater than or equal to a is equal to 5/8, find the value of a. So going over to the graph again, a might be about here, and again this is just an estimate. So a would be somewhere here. The chance of x being greater than that is equal to 5/8. So this area in here is equal to 5/8. So what we're going to do is set up an equation saying, well, if I was to find the area between 5 and a, underneath this function, it would equal 5/8. And I'm going to solve that equation. So let's come down on a bit of better paper. So again, I might take that 1/12 out the front, integrate x, and then let's work our way through this. Now we sub 5 in, so 5 squared on 2 minus a squared on 2 equals 5/8. We may just simplify this one. Couple of places you could go here. I'd probably expand that bracket and have this 25 on 24 minus a squared on 24 equals 5 on 8. I could write that all as one fraction and write this as 15 on 24. So just changing the 5/8 to 15 on 24ths. That makes it really easy for me to do this. Let the numerators equal each other. I'll end up, if I manipulate this and get a squared by itself, I'll get this. I can add the a squared and take the 15 over. I'll get positive and negative root 10. It's really important that you have both of those, and then make a comment about rejecting a equals negative root 10, because a has to be between 1 and 5. If you go back to that original PDF, the a value must be between 1 and 5. We can see that on the graph. So therefore our answer is root 10. Moving on to our second example. So we're given a function, we're given a domain, and we're told it's a probability density function, and we're asked to show that k equals pi on 2. So to show that k equals pi on 2, we really need to show that the area underneath this curve between 1 and 0 is equal to 1. Because it's a probability density function, it's going to be, the area will be equal to 1. So we'll have the integral between 1 and 0 of this must be equal to 1. So here's our show that, and we're going to show that k equals pi on 2. So we're going to solve this equation and get down to k equals pi on 2. So what you need to be able to do here, I would take the k out as a constant. And then we're going to need to be able to evaluate this integral. So you need to look on your formula sheet in the exam, and you'll see that the integral of sine ax with respect to x is negative 1 on a cos ax. So this is going to be negative 1 on pi cos pi x between 1 and 0 equals 1. We will now evaluate this definite integral. So we sub 1 in, and then we sub 0 in. So 0 times pi is just 0. Now we need to know our exact values, so you might want to draw up a little unit circle to remind you. 0 is here, pi is here, and the cos value is the x coordinate of those points. So cos of pi is negative 1, and this can be made into a plus 1 on pi. Cos of 0 is 1. Let's tidy this up a little bit further. Negative 1 on pi times negative 1 is 1 on pi plus 1 on pi equals 1. 1 on pi plus 1 on pi is 2 on pi. So if we go over to here, we're running out of space. 2k on pi equals 1. 2k equals pi. K equals pi on 2. There's our finished show that. So fair bit of work there. I think that was a 2-mark question on the paper. So show that question, you probably want to err on the side of showing a bit more working than a bit less. The second part of this question is a conditional probability question. Let's just get rid of our unit circle here. To help us understand this, and this isn't essential, but I would maybe draw up a quick graph. It's a sine function, and it has a period of 2 pi and pi, which is 2. So normally the whole thing would look like this. We're only interested in up to 1 because of the domain. So we've basically got a graph that looks like this. We want the chance that x, the probability that x is less than a quarter. Probability x is less than a quarter, which is this. Given that x is less than or equal to a half, which is all of this. Now, using some symmetry, the orange area will be equal to a half. Using our conditional probability formula, this will be equal to the intersection of those two areas over the probability that x is less than or equal to a half. The probability that x is less than or equal to a half will be a half. We can see that that's that orange area that got shaded in, the chance of x being less than or equal to a half. So we've got a half sitting on the bottom. The top bit, which is the intersection of the red and the orange, is just going to be the red. So this can be simplified to this. The probability that x is less than a quarter over a half. So we now need to put some time into finding out the value of this. What is the probability of x being less than or equal to a quarter? Which will be the integral of the function. So it'll be the integral of the function between a quarter and 0. So let's do that on another page. So it's going to be, and if you look back yourself, we're going to see that it's the integral. It's not a very good integral sign. Let's try that again. So the integral between a quarter and 0 of pi on 2 sine pi x with respect to x. And this is the top bit of that fraction, and then we're going to end up dividing this by half. I would take the pi on 2 out. We integrate this and it becomes negative 1 on pi cos pi x between a quarter and 0. Now, you can work it through, continue to work it through with the negative 1 on pi in. It's much easier in the long run to take that out at this stage, like so. Take that negative 1 on pi out. Because then we just get negative a half out the front. So I'm really emphasizing these steps. And now we're going to evaluate the definite integral by substituting in the terminal. So let's go up here. Cos of pi times a quarter, which is pi on 4, minus cos of pi times 0, which is 0. Cos of pi on 4, and again, you'll need to know your exact values. You might want to draw up the special triangle, but it's going to be 1 on root 2 minus cos of 0, which is 1. So that is what's sitting on top of that conditional probability. So the answer now, which is this, is equal to and because we can divide by a half, they can cancel. And I'm just left with this, or this. Oh, there's other ways you could write it, but that's the simplest way of writing it. So there's a lot going on there. We needed to know conditional probability, we needed to know our exact values, we needed to be able to integrate the trig function. The graph helped. So you've got to have that really good skill base, solid skill base to be able to do these questions well.